I have made the lectures on first half of the module mathematical induction and recursive relation. But for this part of topic, I'm just recording from my PC and then explaining why, because it's taking a lot of time for 1.5 hour for one topic, so it's too much, I guess. So in this, I'll be just showing you the notes and then I'll be explaining how it is happening so that you will understand how it's happening, and already the steps have been provided in this uh, this PDF. So then the topic which we had to do next was rules of sum and product. As we saw in our syllabus copy, this was the next topic. So what is the sum rule? If T1 and T2 are two tasks such that T1 can be performed in m different ways, T2 can be performed in n different ways. So two tasks are there which can be performed in different ways. So what kind of ways they are denoting as m and n ways? For example, if you have to perform a task of what to say cleaning or what to say that separating some things sorting something, so you can sort either in merge sort in another way, sort is another way, like that. So m ways and q ways are different ways are there. If these two tasks cannot be performed simultaneously, then one of the tasks t1 or t2 can be performed in m plus n ways. Okay, so what is saying, both are performed in different ways, but if they are not performed in the simultaneously, if they cannot be performed at the same time, then one of the tasks is performed in m plus n ways. Okay, example, a library has 12 books on maths and 10 books on physics, 16 books on computers. Okay, suppose the student wish to choose one of these books to study, then the number of ways he can choose the book is. So among these three types of books, he has to choose any one books. So that can be written as 10 plus 12 plus. So all the books are there. So all the books will be kept front, and among that he can pick any one. Right. So total number of books will become 38. So he can read any book in 38 ways. Understood, like that. Then the product rule say if T1 and T2 are two tasks such that T1 can perform same thing, okay, then both the tasks can be performed in m into n different ways. So if you want to do two books at the same time, suppose a person has 8 shirts and 5 ties, then the number of ways of choosing a shirt can and a tie is 8 into 5 times. For example, he has 8 shirts, so one tie for 8 shirts, then all 8 shirts, then second tie, if I have to do, so one tie, 2, 3, 4, 5, right? So 8 shirts are there. This I can wear on all 8 shirts, one type. This 8 shirts. So here I got 8. Then second tie I can wear on all 8 shirts, that is again 8 times. 3 I can wear on all, third tie I can wear on all 8 shirts, that is again 8 times. Fourth tie, like that. So totally 5 times I will have this 8. Okay, so that is nothing but 8 plus 8 plus 8 plus 8, that is 40. That is nothing but 8 into 5. So number of this shirt and like that, that's it, nothing else is there. Okay, now let us go on to let us move on to the problem. A license plate consists of two English letters followed by 4 digits. So here two letters are there, okay, and here 4 digits are there. Okay, if the repetitions are allowed, so what is saying, same numbers can be repeated, like here only a here, or 0 0 0 0, like that is allowed. How many of the plates have vowels, only vowels, and even digits? So how many vowels will be there, and how many even digits can be there? Okay, so each of the first two positions can be filled in 5 ways because of that a e I O U, that's these are the vowels. So each of the two positions can be filled in 5 ways, and each of the remaining 4 places can be filled in 5 ways. Even numbers is there. So see, even numbers, 4 digits is there. So each digit, okay, so it can be only single digit, right? So single digit even numbers I'm taking. So 0 to 8 only, it's a single digit. So I take consider 10, it is also even, but I cannot place that in one place because it will contain 2 digits. So I am taking only 0 to 8. So how many numbers I have here? 5. So simple. Now I have number of vowels and number of digits which I can put in that. So basically what I can do, I can simply multiply number of possible license plates of the given type is. Now see here, how many places are there? 1, 2, 3, 4, 5, 6. So these two places I can so here one vowel will be there. Among 5, any one vowel can be placed. Among 5, here also any one vowel can be placed. So this 2, if I have to take combination, that will, I will simply multiply this 2. So that is 5 into 5 I have written here. Similarly here 5 digits I have 0, 2, 3, 0, 2, 4, 6, 8. Again here 5, here 5, here 5. So this I can 5 into 5 into 5 into 5. 5 to the power of 4 times I can place. Here 5 square times. So I just multiply, it will become 5 to the power of 6. From the calculator, if you just calculate it, you will get this as your answer. Similarly, another question here. It is cars of a particular company comes in 4 models. Okay, so see here there are 4 models. Okay, and then 12 colors, 3 engines, and 12 transmission, transmission types. So now what it is saying, how many distinct cars of this company can be manufactured. Now see here, this is 4 models, each model can have 12 colors, each model can have 12 colors. So these are all are distinct itself, and each of these can have either of the engines. From 3 engines, either one engine can be there. Okay, either three engines can also be there, and from 2 transmissions, both any one 2 transmissions also can be there. So it will be like first model with first color, with first engine and first transmission one type. Same way, first model, second color, this is like that. So they are asking how many of these cars of the company can be manufactured, distinct cars. So I will simply multiply this into this, into this, into this. Why? Because if you just try to get on like each model, one model 12 colors, so 12 are their cars there itself happen. But each 12 cars can be in 3 engines. So each car will each color of car will be having 3 engines. So 3 will be in 12 times. So 12 into 3 will come there itself. Then so how many was 12 3 is 36 cars with 12 colors and 3 types of engine. All are, if then 2 transmission, then this will become into 2. So 36 into 2, 60, 66, 72. Now from in one model I have 72 I can distinct cars are there. So 4 models are there. So 4 into 72 I will take. Okay. So that's what my answer. So that same way, if you do 4 into 12 into 3 into 2, you will get 288. 72 into 4 is also 288. Same way I just wrote here. Na? See here 36 was there. How 36 came? 3 into 12, right? 3 into 12, and then again I multiplied 4. You are understanding, right? What I am trying to say here. Similarly, okay, I hope you understood what I explained here just now. So now B, sub question B, that is of these how many have the same color. Okay, so how many cars will have the same color. So now what I will do, I have instead of 12 colors, what I will do, I will only take one color. Okay, because I need the same color, right? So all these number of cars, okay, except for colors, what I'm doing, 4 types of model, 3 types of engine, 2 types of transmission, but only one color I'm taking. Instead of 12, only one I'm taking. So here into 12 we did, here instead of 12 I will do only one. So these many cars I'll have for what to say, with only one same color. Okay, so each color has 4 models, 3 types of engine, and 2 types of transmission. So if you add this 24 into 12, if you do 24 into 12 now, because you took only one color, if you want in all the colors, distinct colors, so see here, distinct cars, so that will give us this itself, it will give us. You understanding, right? Okay, so let us move to the next question. Find the number of 3 digits even numbers with no repeated digits. Consider the number. Okay, so they are saying number of 3 digits. So 3 digits I have, 3-digit number of even. All it should be 3-digit number should be even. Like 0, 0, 0. Don't let us not take 0. So I can take 2, 4, 6. Okay, these all are even digits. So like 100, 102, like that, so on. Okay, it should not repeat any number. For example, 1 2 2 2, it should not repeat like that. Okay, so how many okay, find the number of, okay, how many like that 3 digits I can do. It's from starts from 0 to sorry, 100 to 999. These are the 3 digit possible numbers, right? In this, how many even numbers I can take, and in that any number should not repeat. Okay, so I'm saying let xyz represent a digit. Since xyz has to be even, which belongs to z, has to, so z has to be 0 2 4 6 or 8. So each thing should, okay, so what he's saying, z has to be 0 2 4 6 or 8. So first two I'm leaving as it is. So last number it decides, is it even or odd, right? For example, here 1 2 was there. in the last number, if it is 0, it can be like that, what to say, 2, it can be 4, like that, 6, 7, 8. So if z equals to 0, then x has 9 choices and y has 8 choices. Okay, how they are saying 0 to 9, 0 to 9, I am taking, okay, if I just write it somewhere here, 0, 1, 2, 3, 4, 5, 6, I'll write here 7, 8, 9. So I'm taking 0. If I take 0 from 1 to 9, only 8 are there. Okay, so that's why I'm saying x has 9 choices. Totally 10 are there. 1 to 9, 1. If I consider 1 till 9, that is x will have 9 choices, first place. So it cannot be 0, right? So 1, 2, it can be 1, 2, 3, 4, 5, so on up to 9. X and y similarly, I cannot take 1 for y. Why? Because it has to, it should not repeat anything. So I have to take from 2. So 2 so on up to, I'll take 9. Okay, here don't consider this up to 9 I'm taking, but at the last place 9 and won't come. Okay, remember that. Then what I'm saying, okay, when y has 8 choices, if z is equals to 2, 4, 6 or 8, then x has 8 choices and y has 8 choices, like that. If it is either these two things. Why? Because if I'm taking 0, if I'm taking 0, where is one? Here, if I take 0, here 0 and all won't cannot come, right? In x place 0 cannot come. Why? Because it has to be a 3-digit number. So here I'll consider 1 to 9 itself. But in y place, I can use 0, but I cannot use 1. Okay, since I'm using 0 here, so here 0 won't come and here 1 won't come. So this won't come here, this won't come here. So it is 10 minus 2. How 10 means 0 to 9, it is 10, right? So in that these two digits are gone for that. So only from 2 to 9, that is 8 are there. But if I am considering 2, 4, 6 or 8, any 4 of this number, so here I cannot take one number will be like can't be used, 2 or 4 or 6 or 8. You're understanding, right? So either it's like or not, and I'm not taking all 4 together. Any one can come here. So here I cannot take, what to say, if here 2 is there, in both the here 0 anyways I cannot take itself. So already here 1 to 9 was there. I'm taking 2. So among 1 to 9, if I remove 2, so here only 8 numbers will be remaining. Here anyways already if 2 is here, so same way here also 1 to 9 I can use, right? In that 2 is or not cannot be used. That's why I cannot use, what to say, this also will be in 8 ways. Okay, note that y can take 0, x cannot take 0. Why? Because x cannot take 0 because 3 digits, right? X, y, z. X, if I take x as 0, then it will become 2-digit number, not 3-digit number. Okay, I'll erase this. Now the distinct desired numbers are, okay, 9 into 8 into 1. This when I am considering that as 0 plus 8 into 8 into 4. This 4 is these 4 numbers. Okay, 2, 4, 6, 8. So it can be either 2 or 4 or 6 or 8. Total 4 numbers. And I can write it in 8 into 8 times. You understood why here 8 and here 8. You are taking 2 here. Okay, uh, 1 to 9. So see here. Okay, once again. I'll explain it again once properly. So, right, x I should write only from 1 to 9. Y I can write from 0 to 9. And z I can write from 4 ways, 5 ways, 0, 2, 4, 6, 8. Now when I take z as 0, here obviously I cannot use 0. So 8 can be written, y can be written in 9 ways. That will become 8 now. Why? Because I took 0. And x, I can anyways I cannot write 0. So it was already 1 to 9. So I'll take 1. If I'm taking 1 for x, then I cannot write 1 for y. So from y will become 0 is not there. So 0 to 9 is 10 totally. Okay, sorry, it is from 0 to 9, it is 10 totally. Y can be written in 10, not 10 numbers can be written in y place. Since I took 0, so it will become 9. And since I took 1 here, so it will become 8. So 0, 1 gone, so 2 to 8 like that. Now when I am taking 2, 4, 6, 8, if I am taking 2 here, 0 can be written. Okay, like I said, 0 to 9. If I am taking 2, in y 0 can be written. So it will become only 1. And here if I am writing, if I am taking 2 here, I cannot write 2. So 1 to 9, totally 9 are there. So x will become 8. Because 0 cannot be written in x place. So already I had 9 numbers I can write, but I took 2. So among that remaining 9 numbers, I am removing 2, so I can write only in 8 ways. Now that's why it is 8 ways here. Okay, and this 8 total I can write in 10 ways, but I am retaking 2 for z. Okay, so if I take 2 for z, then here some other number will come, right, x. So it should not repeat. So two numbers are being taken from y. From 10, two numbers are being taken. So that is also 8. Like that itself, we are getting the desired number is 9 into 8 into 1 plus 8 into 8 into 4, that is 72 plus 256, that is 328 ways. Okay. Now a bit is either 0 or 1. A byte is a sequence of 8 bits. So bit can be 0 or 1, and then we have byte. Byte is having a total 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this much long bit it is, byte it is. So now what I have to find the number of bytes. So see here, each can be either 0 or 1, that is 2. I can fill it in two ways, 0 or 1. So same way, 8 position is there. So 2 into 2 into 2 into 2, like that, 2 power 8. So understood, right? 2 will be multiplied 8 times. So same way, nothing but 2 power 8. So how many number of bytes will be there? That is 2 power 8, that is 256. Second question, the number of bytes that begin with 1 1 and ends with 1 1. Now see here 1, and here 1 1. This can be either 0 or 1. This will be two ways, two ways, two ways, two ways. This I am filling in only 1 1. So same way you have to multiply. So it will be only 2 power 4, I guess. See here, you understood, right? Only 2 power 4 ways. That is equal to 16 ways. Third question, the number of bytes that begin with 11 and do not end with 1 1. Okay, it begins with 11 but do not end with 1 1. So it can begin with 11, but it should not end with 1 1. So here it should be 0 and 0. Now see here, third question. In a byte beginning with 1 1, there are 6 empty positions. These can be filled in 2 power 6 ways, that is 64 ways. But it should not end with 1 1. Okay, so but there are 64 bytes that begin with 1 1. Now since there are 16 bytes that begin and end with 1 1. Okay, the number of bytes. Okay, so since we got here 16, I got here as it will begin with 1 1 and end with 1 1. But the number of bytes, okay, begin with 1 1, end with 1 1 is 16, which only begin with 1 1, that is 64. Okay, 64 only begins in 1 1. This begins also and ends also with 1 1. So if I subtract this, which ends with 1 1, right? Both are there. So what I have to do, I'll just subtract 64 and 16. That's what they are doing here. 64 and 16 is equals to 48. Okay. Then fourth question, the number of bytes that begin with 1 1 and do not. Okay, that is a third question. So number of bytes that begin with 1 1 or end with 1 1. So either it should begin with 1 1 or it should end with 1 1. So what I will do, first I will find the number of bytes beginning 64, that is beginning with 1 1. Then what I will do, it should end with 1 1. If it is beginning with 1 1, this can be 2 and this can be also 2, right? Two ways I can fill, 0 or 1, 0 or 1. Only there is beginning with 1. And if has to 1 with 1 1, this I can write as two ways. So I have to just add that 64 plus 64. Okay. Now again one more thing which I do is the number of bytes that end with 1 1 is 64 by result 3. I also number of bytes that begin and end with 1 1 is 16. The number of bytes that begin or end with 1 1 is. So here they are using this union formula for any two finite sets A and B. A union B is equals to mod A plus mod B minus like this. Okay. So 64 plus 64, A and B we found out, right? Minus A intersection B, that is 16. Okay. So you understood, right? How see which begins with 1 1. This is begins with 1 1. This is begins ends with 1 1, and this is minus which begins both with 1 1 and 1 1. So that will give me A union B, which can be either A or either B. 64 plus 64 minus 16 is equal to 112. Just remember one thing here. You can see the pattern also here. Previous answers are relating for okay. Current answer really depends on previous answers. Find the number of proper divisors of 4 for 4,41,000. Okay, so we have to find the proper divisors of 4,41,000. So all are divisors excluding one and itself. So we have 4, 4, 1, 000 is equals to 2 power 3, 3 power 2, 5 power 3, 7 square. Every divisor of n is equals to 4,41,000 must be of this form. D is equals to 2 power p, 3 power q, 5 power r and 7 power s, where 0 less than equals to p less than equals to 3. Same way, q is less than 2, r is less than 3 and s is less than 2. Okay, p can be chosen in 4 ways. Q can be chosen in 3 ways. So see here, they have multiplied here, right? So how we got these numbers is nothing but they have taken LCM here. So 2 has come 3 times, 3 has come 2 times, 5 has come 3 times, 7 has come 2 times. The same way they have filled here. Same way they are setting how many times P. So we are considering this as P, Q, R, S. How many times P3, how many times Q2, how many times R3, how many times S2. So thus the total number of divisors is equals to, okay, how many ways? 4 times, 3 times, 4 times, 3 times. 4 into 3 into 4 into 3, that is equals to 114. So, but the total number of proper divisors is equals to 114 minus 2. Why? Because why are doing 2? Because we are removing 1 and that number itself. 4,42,000 right? Sorry, 41,000. So this two numbers we are removing. 1 and itself, the number itself. Total number of divisors are 144. How means it will include 1 and this number itself. So I want proper. So I will just subtract 2. It was 142. Okay. Again we have this license plates consist of 2 letters followed by 4 digits. In how many ways can this be done? If no letters or digits can be repeated. Okay, so first see here they are saying letters in 2 ways, digits in 4 ways. Since there are 26 letters in English alphabet, the first place has 26 choices. Second place has, okay, here I will have 26 choices. So it can be anything from A to Z. But it should not repeat its saying. So this place I'll have one less letter. Why? Because it won't, if it was repeating, so both the place I can fill 26, but I'll fill it in 25 ways. Why? Because I am just removing one letter. Since if suppose A to Z 26 are there, if I am using A here, I cannot use A here. So if I remove A from alphabetical order, alphabets, so if A is removed, so 26 minus 1 is A is that is 25. So this I can fill in remaining 25 ways. Okay. Similarly, here how many digits I can place? 0 to 9. Okay, 0 to 9. So here it is 9 ways. So if I am using this here, I cannot use here. So this will be 8 ways, this will be 7 ways, this will be 6 ways. If I am using 9, 8, 7 here, so obviously from 0 to 9 I have to remove this 3 letters, that is 0 to 6. That is nothing but 6 ways. Okay. Now what I have to do? I have to just multiply this into this, into this, into this, into this, into this. 26 into 25 into 10 into 9 into 8 into 7. Sorry, here it is the 10. Why? Because I am considering 0 to 9, right? 0 to 9 is 10. So this will be 10 ways. This will be 9. This will be 8 and this will be 7. Okay. Okay, so I have to multiply 25, 26, 10, 9, 8, 7. So I'll get this number, either write in that 32 into 32.76 into 10 to the power of 5 or like that, but write in full form. Then second question they have asked here. Repetitions are allowed. If repetitions are allowed, here 26, here 26, here 10, 10, 10, 10. Okay, see. It's not dependent now. So here also 26 types I can fill 26 ways. Here also 10 ways I can fill the digit, 10 ways I can fill the digit, same like that. Okay, I'll have this one. Then third question, only vowels and even digits can be used. Same way we did in the first question which we did here, right? Only vowels and that thing, same way. So 5 into 5 into 2, same way, 5 into 5 into 5 into 5. Okay, that is 5 power 6. Okay, then next question, find the total number of integers that can be formed from the digits 1, 2, 3, 4 if no digit is repeated in any one integer. So like they are saying we are using only 1, 2, 3, 4 numbers here, and we have to see how many numbers it can okay, integers can be formed. I can replace this position, but it should not repeat. Okay, so let S1, S2, S4 denote the number of integers containing 1 digit, 2 digit, 3 digit, and 4 digit respectively. S1 is equals to 1 digit only. Four choices are there. So S1 can be okay. It will be 1, 2, 3, or 4. There are 4 integers containing exactly 1 digit. Since S1 is equals to 4, a 2-digit integer without repetition can be chosen 4 into 3 ways, that is equals to 12 ways. So therefore S2 is equals to 12 ways. Okay, see what they are saying. Only one I have to place, one digit number like 0 to 9. So I can write it only in 4 ways. This itself one number, this itself one number, this itself one number, one number. So one by one if I take, so 1, 2, 3, 4. These are my only one digit numbers. Now I have to take two digits number, which is from 10 to 99. From 10 to 99, it should not repeat, right? So see here, two digit place. This I can fill in 4 ways. If it is not repeating, I have to reduce one. So it is 3. 4 into 3 ways. Similarly, 3 digit number. This can be filled in 4 ways. This can be filled in 3 ways. This will be filled in 2 ways. Similarly, 4 digit number. Here same 4, 3, 2, and here 1. So what I will do, this 4 rays, right? Now same at the end totally I have to add. So what was the value of S1 is 4. Okay. How 4? 1, 2, 3, 4. 4 ways it can be filled. S2 4 into 3. 4 is 12. Then S3 4 into 3 into 2, that is 4 is 12, 12 2 is 24. And even S4 can be same because only into 1 is 24. So I have to add all this thing. So it is 4 plus 12 plus 24 plus 24 gives me 64. Okay. Determine the number of 6-digit integers. No heading zeros. 6-digit integers in which, okay, no leading zeros, no leading zeros in which number of digits. So I have to find no leading zeros means first thing cannot be 0. First digit should not be 0. Leading means which will lead, right? So first number should not be 0. Okay. So one, I have to find no digits is repeated. Same way, how many? 1, 2, 3, 4, 5, 6. So 6 digit numbers are there. So each place I can fill with 0 to 9. How many numbers are there? 10 are there. But first thing I am removing 0, so it is only 1 to 9. So if I can 1, 2, 3, 4 like that, so on up to 9. So this can be filled in 9 ways. Same way, this digit. Here I can use 0 now. Here I cannot use one number. So here I can fill it 10 numbers actually, but I am using 9 here, one number here. So this will be also 9. How? Because here 0 was not considered. That's why it was 9. But here 0 can be considered. Even if I remove 1 from here, suppose 0 to 9 it is again. Here 0 can be used, right? But I am taking 1. Suppose 1 is taken here. So that 0 to 9 is 10. But I am using one digit here apart from 0. But here I am using 0. So obviously 0 to 9, if I am doing any one number apart from 0, that will become 9. Same way this, it will decrease and go 7, 8, 7, 6, 5. You just have to multiply these numbers 9 into 9 into 8 into 7 into 6 into 5. Okay. This you will get the answer properly. Second, they are saying no digit is repeated and it is even. So you have to select, instead of 0, 1, 2, 3, 4, 9, you have to select 0, 2, 4, 6, 8 now. So first place it cannot be 0. So what are the ways it can be filled? That is 4 ways. Okay. Then second way, if I am taking considering 2, so it can be filled in again 4 ways itself. Why? Because 0 can be considered. If I am taking 2 here, still here it's 2 numbers are going. So remaining 3. 3 numbers are going. This is 2 ways. This is then at the end last 1 ways. Okay. Then here okay, if the last place is 0, case 2. If the okay, it should not have no leading zero. So here again we are considering last number cannot. 1 second, I was just yawning. Okay. So here either first number cannot be 0. Ouch. Okay, no digit is repeated and is even. Okay. no digit is repeated and is even. Same way, okay, now see here the last, okay, case 1, okay, we have two places. One, sorry, the same way we had found in the beginning question here. I forgot to mention that. We had here, right, somewhere that even, see here, somewhere, I think this itself it was, right. So if it is 0, then I have 4 choices. If the large is just 2, 4, 6 sets, then I have these many choices. Yeah, same thing will happen here also. Now see here, I'll erase this for removing the, what to say, confusion. Now if it is 0 here, now from 0 to 9 I can fill anything here. So this will be 0, I'm not using. So here only 9 out of 10 numbers, 0 to 9, 0 is gone, so here 9, here 8 times, here 7 times, here 6 times, here 5 times. Here it will be 0, so it will be 1. Then if I am using the last place as 2, 4, 6, 8, so see here they have written here, it can be either 2 or 4 or 6 or 8, so it is last place is 4. So here 0 cannot come, so here it will be 0 to 9, so 0 cannot come, so it will be 1 to 9. Among 1 to 9, so one of the number is taken in the last place. So here again 1 to 9 is total 9 numbers, again one number taking, so it is 8 numbers. Here I can include 0. So again 0 to 9, in which 1 was already taken here. So here also 8 will be there. Now 2 numbers gone from our total 9. So here 7, 6, 5. Here into 4 will come. Why? Because it is 2, 4, 6, 8. Okay. We have to multiply this. So what you multiplied here, take that as one number. And what you got here, multiplication value, that has 2. So S1 plus S2. This I am taking as S1, this I am taking as S2. If you add the value, what you are getting, you have to write here. Okay, let me just calculate in my calculator over here. So see here, I have 9 into 9 into 8 into 7 into 6 into 5. That gives me 136080. Okay, it gives me 136080. And here, okay, 8 into 8 into 7, 6, 5, 4. That gives me 53760. Okay, plus I'll add this plus this one. Okay, then I'll get the final answer as, okay, here 189840. Okay, then I have a case 3. Okay, third question also they have asked. Okay, no digit is repeated and is divisible by 5. It should be divisible by 5. So for it to be divisible by 5, either the last number should be 0 or it should be 5. Then only we can divide by 5, right? Case 1, if unit place is 0, last place is 0, then how many times? Same way here, first number cannot be 0, so it will be 0 since it is taken here, so here it will be 1 to 9 ways, and here 8, 7, 6, 5. If it is 5 here it cannot be 0, and here no 5. So 0 and 5 is taken from this 0 to 9. So from 0 to 9 total 10 numbers, 0 and 5 is taken, 2 numbers are taken, so it is 8. Here it can be 0, but it should not be 5. So among 0 to 9, only 5 is removed. So here it is 8, okay. 0 to 9, okay, and here 7. So 0 to 9, in that 5 is taken. Here 5 is taken, but 0 can be taken. Then here 6, then here again 5. Here don't multiply with 5, here only it should be into 1 because only constant it is. So you have to multiply this, add, you will get S3, and here I add something, you will get S4. So you have to add S3 and S4. Just multiply in calculator, you will get one value. If you want, you can just skip this video fast forward. I will just calculate and write it now itself. 9 into 8 into 7 into 6 into 5. So here I will get 1, 5, 1, 2, 0, and here now 8 into 8 into 7 into 6 into 5. Here I have 1, 3, 4, 4, 0 plus 1, 5, 1, 2, 0. So the final answer we'll get is 2, 8, 5 6 0. Okay, done. So that part of done is done, sum and that product. Now we'll go for permutations. Linear arrangement of distinct objects is called permutation. Linear arrangement of distinct objects. Suppose we have 5 objects. So how that objects can be arranged like that? It is okay. Number of arranging r distinct objects out of n objects is denoted by p of n comma r. N total number of objects are particular number objects you are arranging, or npr. N p r in the like the suffix r, and p of n comma r is equals to n into n minus 1 into n minus 2, so on up to n minus r minus 1. Okay, so this I'll write as n factorial divided by n minus r the whole factorial. Now you don't have to worry how you got this. They won't ask this. Suppose if they ask, you have this definition. And just definition is enough. This is the basic formula, and you won't be having handbooks, so you have to remember all these formulas. N factorial divided by n minus r factorial. Now note. Let us read the note. Number of different arrangements of n objects taken all n at a time is equals to n factorial. So total n objects are there. I have to arrange all that n objects. So how many ways I can arrange it? I can arrange it in n factorial ways. Suppose I have two objects, okay, a and b. I have to arrange it. So first I have arranged it a b, then I have arranged it as b a. So no, is there any other way? So two objects is there. What is 2 factorial? 2 factorial is 2. So I have arranged two ways. Suppose if you take a b c, what is 3 factorial? That is 6. So I can arrange C. First I will take A B C, then A C B, then I will take B A C, B C A, then I will take C A B, and then C A B. Understood, right? Like that. Suppose we wish to find the number of permutations that can be formed from a collection of n objects among 0 to n. Some, okay, this is n. Some particular thing I'm taking, collection I'm taking, okay, of n objects, of which n1 are of type, n1 are of one type, n2 is of another type, and n3 is of third type, so on up to nk is of kth type, and n1 plus n2 plus so on up to nk is equals to n, total number of ways. Okay, then number of permutations of n objects taken all at a time is equals to n factorial divided by n1 factorial, n2 factorial, so on up to nk factorial. This is also one formula. Here n is total number of objects, k is number of times you have taken that objects. Okay, then circular arrangements of n different objects. Circular arrangement of n different objects is n minus 1 factorial. So it is a circular factorial, right? This first and last is same. First arrangement and last arrangement is same. That's why it won't repeat. Instead of n number of times, it will repeat one less. Then problems we have here. Okay. First, 5 men and 4 women sit in a row such that the women occupy the even places. How many such arrangements are possible? Now you can see here 5 men be seated in 5 factorial ways. Okay, how 5 men can be seated? In arrangement nothing but here seated arrangement same in 5 factorials, and 4 women can be placed in even places in 4 factorial ways. So the total number of arrangement is 5 factorial to 4 factorial. Simple. See, they have given you this even and odd just to what to say, confuse you. That's it.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.